Thank you, Dan. Thank you all for coming to my talk here. I am Skip Cruse. A little bit about myself here. I am the adversary simulation and red teaming lead for Baxter Healthcare out of Deerfield, Illinois. I've been in InfoSec since 2010, and my specialty is adversary simulation, purple teaming, red teaming, that kind of thing. Prior to, in a past life, I was a Splunk guy, and I've since recovered. As a second life, I also build and race BMW race cars, and I own a company for that as well, so if you have one you need tuned, let me know. I'm also a member of the Woo Woo Cybersecurity Collective. Some of you may have remember that from the 90s when we used to publish papers on buffer overflows and things of that nature. We are coming back, and we're going to be better than ever. As there is a live demo in this talk, and the guy in the next room is screwing with the Wi-Fi, I have brought a chicken to ritualistically sacrifice to the demo gods. So we'll go ahead and get that out of the way. So hopefully the demo gods are appeased. So, all right. So what is DNSRazzle and what does it do? DNSRazzle is a tool for detecting typo-squatting, homoglyph domain, and other brand impersonation techniques using computer vision and AI. What is typo-squatting? Typo-squatting is where somebody will buy a domain similar to your domain that uses either a homoglyph or different character set of text, or they swap vowels, or they'll do numbers instead of letters to then try and mimic your domain to be able to fool suppliers into fulfilling orders or getting you to put in credit card numbers, things of that nature. So what is DNSRazzle? DNSRazzle is an open source tool for detecting brand impersonation. It utilizes computer vision and AI to automate detection of imitation domains. It's entirely written in Python 3. And it also can offensively fingerprint attacking infrastructure using Nmap and a variety of other features. It is currently available on GitHub, and it is Apache 2.0 licensed. If you want to add a feature to it, please send me a pull request. If you find something wrong with it or it's not working for you, please send me a pull request. It also works cross-platform. It'll run on Windows, Linux, and Mac. And as of about 2 months ago, it also now works in Google Shell. So. What is computer vision? Computer vision is a process that seeks to develop techniques for helping computers see and identify the content of what's on the screen, whether it be an image, a video. It uses these techniques to be able to tell what's in the image and infer what it is, rather than strictly relying on the metadata described and supplied by the end user. So this way, you have a process that'll look at a picture and say, yes, that's a tree, instead of having the user have to type in, this is a tree. How do computers see? Well, the number one way is with image processing. Image processing is the process of creating a new image from an existing image, typically simplifying or enhancing or changing the content in some way as you go. It's a type of digital signal processing, and it is not concerned with understanding the content of the image, strictly what is there. DNSRazzle, for its computer vision component, uses the OpenCV and Scikit image libraries. There are a number of ways that you can tell what's in an image, but the two main that are used is going to be either the mean squared error equation or the SSIM equation. MSE is the easiest to implement, but it does have its problems. The SSIM is harder to implement, but it does solve a lot of the problems posed by the mean squared error technique. So here's the actual equations that are being done under the hood for each one of the different techniques. For MSE, as you can see, it's a lot shorter, and I don't even begin to understand the math because I'm really bad at math. But luckily for us, Python has modules that understand this math and does it really well. So with MSE, what you're detecting is the mean squared error of two images. And one of the biggest difficulties with that is that when you use mean squared error, having vast pixel densities that are different do not necessarily mean the images are alike or unalike. So if you have a big white space in an image, that'll screw with MSE. Whereas with SSIM, it's much more complex, but it attempts to model the perceived change of the structural data of the image rather than the errors and the differences. It's important to note that a value of 0 for the MSE equation result indicates perfect similarity. With SSIM, you're trying to get closer to a 1.0. The farther lower you are from 1.0 is your less similarity with SSIM, whereas with MSE, the higher your number is, the more different it is. So how does SSIM work? Well, SSIM takes a reference image and a comparison image that you provide. It'll then go through and it'll go through and detect the artifacts in the image. And once it does that, they're outlined with bounding boxes. The image is converted into grayscale, and then the bounding box image is compared and they're overlaid. And I'll go through all this one step at a time here in a minute. And then it calculates the differences based on those bounding boxes. So in the first step, for this example, we're using google.com and apple.com, which are fairly different sites. You can see where it'll go through and find the differences with the artifacts and bounding box them. From there, it converts the images to grayscale, and they are overlaid. Then it makes the threshold image out of the combination of them. And then using that with the bounding boxes, it'll then generate the score using the SSIM equation. I have a POC script that you guys can download if you would like. All it does is you give it one domain, or give it two domains, and it'll go through, it'll take a screenshot of both domains, and then it'll automatically go in and run the SSIM measurement on it and give you a score. It's available publicly on my GitHub. I'll have a, if you want it, you can go ahead and, if you feel daring, you can scan that QR code. I assure you it's safe. Or if you don't feel like scanning the QR code, you can also just go to my GitHub, which is github.com/fatal, FATAL/site compare, and that'll get you the version that you see here. It will require a couple of modules to be installed for Python, but it does come with the requirements.txt, so you can just go ahead and install that at your leisure. So how does it work? Well, the first thing it does is it takes a screenshot of your first domain that you provide it, then it takes a screenshot of the second, and then it will generate the SSIM score, and then depending on whether it is a 1.0, a lower score, or a higher score, it will tell you whether the two domains are identical, similar, or different. In this case, google.com is different from apple.com, and the score that it gave it is a 0.82. Does that make sense? Okay. So here's the part that's going to be the fun one. This is going to be the actual DNSRazzle demo will happen after this, but I'm going to talk a little bit more about it first. If you're interested in checking out DNSRazzle yourself, this will take you directly to the repository for it. So how does it work? Well, it uses the Selenium WebDriver, which if you were in here for the previous talk, I am not one of the bad bots. It uses a Selenium WebDriver to go ahead and use a headless browser to grab the screenshots of both the reference domain that you provide initially, as well as the domain you're wanting to compare it to. Then it uses computer vision to compute the discovered domains and give you the SSIM score. It'll return the SSIM score, and then it will output whether the pages are identical, similar, or different. And it also writes all this to a file, so it's really easy to just grep through it for those particular keywords to find things that you're going to want to do manual analysis on later. So let me go ahead and switch back over to my terminal here, and I will show you guys how this actually works. So I am not running on a hotspot at the moment, so if the internet is broken, blame him. So Okay, so we're going to go ahead and I'm going to use the KernelCon website for this, for the first run. So I'm running this in a virtual environment using Conda because I'm on an M1 Mac. If any of you have an M1 Mac and you're wanting to run this, you will have to use Conda to install scikit image as well as OpenCV because there is no egg or wheel or anything like that provided through PyPy to be able to get those modules onto ARM64 at the moment. The only way to get it is through Conda Forge. So we're going to give it kernelcon.org, and I'm going to tell it to output it to /temp, so I don't have to worry about this all getting in my directory here. Oh, can you not see it? How about now? Okay. So I'm going to tell it to run it to temp, and we're just going to kick it off here. So I could try. Is that better? Okay. So it does take a little while for this process to run. It does determine all the possible domain names that it could do, either through typo-squatting, homoglyph, vowel swap, number swaps, all of the different types, and it came up to a total of 5,733 that it's going to be testing. And what it's doing right now is it's going to go through and process all of those to come up with, to make them into a dict, and then it's going to go through that dict and it'll run whois queries to find the ones that are actually active. Once that completes, it'll return a DNS recon, it'll print everything to the screen, and it will give you the name servers, the A records, does it have MX records, does it have the abilities, well, does it have the ability to send mail? And that goes back to the MX records. And it will also give you the date that it was registered as well as the last time it was modified. Because if they're dormant for a long time and they change, that's something that you want to be notified as well with this. What you can also have it do as a possibility of this, if you tell it the option to, it'll run DNS recon on everything it detects as well and give you that full style report out. And you can also have it run nmap on anything that it finds as well. So as we can see here, like I said, this does take it a moment to run. But it will get there, hopefully, unless the internet goes out. Currently there is, you can ignore this deprecation warning at the moment. It's relatively new that it popped up. My box updated my Python modules, and I did not want to try and fix that before this for the sake of the for the sake of the demo not working. But so there we go, 5.3. We're almost there. You can do it. Oh, come on, don't stall there. I need more chickens. But so once it goes through and runs through all the permutations, it's going to start going through and running whois on all of the domains that it does detect. Oh, there we go. And so here's the output that it will give you on any domains that it finds. As you can see, we got the original domain at the top for kernelcon.org. There is all of the DNS records for kernelcon, as well as the NS records and the what the HTTP server is that's serving the site. In this case, it's running on a GitHub Pages site. What the SMTP records are for it, for the MX, can it send mail, who's the registrar, and when was it created. And so if you look at the first one here, we have found a domain that is bit squatting on kernelcon. Unfortunately, it is kernelcon themselves. I was really excited when I found that this morning. I was like, oh, that's great. But no, it's them. And if I had let it run, it would have told you that there was a 1.0 similarity score because it is the exact same site. But as you can see, it's also using subdomain swaps for the ones below there to find other sites that could be mimicking kernelcon.org, such as cur.nelcon.org, and it also gives you who the registrar is, when it was created, and the rest of the domain information about it. So let's go ahead and run this on another domain where we have actually found impersonation. And we'll run a little bit faster, actually. Baxter. So I'm going to run this on, we run this about once a week at Baxter to try to find new domains.
How do you figure out the list of typo-squatting domains in the DNS twist?
On the back end, it is currently using the DNS twist permutation generation library. It will be moving away from that. The guy that wrote DNS twist recently refactored everything and completely broke backwards compatibility with anything that was using his classes previously. So to avoid that in the future, the current plan is to just basically rip the permutation generation out of DNS twist and make it into our own library. And the other purpose of that is going to make it where we can then add plugins to make different permutations to what DNS twist already does.
And if I straight into my DNS service like Fish Labs or...
So if you want, there is a plugin for this code on my GitHub to automatically send takedown emails if it comes back with a 1.0. So everything gets dumped into text files, and so from there you can put it to wherever you can pipe it to wherever you want, however you want to.
Okay.
The primary way that we're doing it right now is we go through it, we run it once a week, we analyze we let it go through, run through all of the domains that it detects, then we go through and we look at anything that has above a 0.85, and then from there we'll go through, do manual analysis, and then we go ahead and do our takedowns. If the ISPs, we're working with a bunch of different registrars that know who we are, and we have partnerships with them. And those guys, we just send them over the nice thing about this is a lot of registrars will require proof to be able to take down a website, and this provides them with the proof they need. We have A, the screenshot of the site, B, the fact that we have proof that they have MX records set up, that they are sending email, that it was recently registered or that the registration was changed, et cetera, et cetera. And this gives, we've worked with registrar partners to specifically figure out which information we want to, or what they want from us to be able to get that information in this blob that it drops.
Once you find a site that appears to be fairly similar, do you also scan all the links down to it to see the tree of links from it? Or basically, how much did they copy from the site when they were cloning it, or do you just stay at the root of the site to start with?
We do that as part of our manual analysis portion, but primarily we just look at the content of the site to see if it is somebody trying to impersonate. When this completes, there is one that it will show that I'll pull up that is currently trying to hit us, and they actually are running beef in the beef hook in the website to try and steal stuff as well.
And do you find repeat offenders where you take down who's cloned yours, and then you can tell it's the same people that are now doing it again or doing a very similar operation?
We don't know for sure if it's the same exact people, but we do have repeat offenders as far as registrars go. The one that's been the biggest thorn in our side since we started this has been Pork Bun. Pork Bun doesn't seem to have any verification to make sure that you're not just stealing somebody else's domain or anything like that. They'll just let you register anything. Doesn't matter if you're going in a different Punycode char set or anything like that. And we've found so far, I want to say we've taken down 25 through Pork Bun, as opposed to where we've looked at things like name.com and other enom, et cetera, where we see one here or there, but Pork Bun's been the one that's been the most. And I assume it's just because of their lack of what they're doing. So here we go. Let me scroll up a little here. So when you're working with stuff that actually has a lot of this hitting you, you can see there's a lot more responses that we get here than what we got when I ran KernelCon. And you also have a lot more interesting options here than the other one. So we have addition, which is adding letters to the domain that we're showing up there. So it's like Baxter A, Baxter B, et cetera. We also do bit squatting, which is swapping bits. If I go farther down here, we also have replacement, and then where's the homoglyphs? There we go. So if we look up here at the first homoglyph that it's found, that xn-bxter-gra.com, if you type that into a browser, it'll return Baxter with an umlaut over the A. And that is one that we're currently dealing with. And it is the one that is running beef. I'll pull it up in a moment here. But as you can see, it's found out that it's registered through, it's actually using Namecheap. It is running a postfix for an SMTP server, so it can send mail. And and you could tell that it was created recently. It was created last December, and it is currently pointing to an IP address, so it should have content. So let me go ahead and pull up a browser here, and we'll see how good of a job they did cloning us here. There we go. So this is theirs, not this is. So if we refresh it here, looks pretty good to me. If I did not see that it was one, no SSL, and two, the umlaut, I would very much think this is the Baxter domain, because if you go to our actual domain, or is my internet not working all of a sudden? Nope, helps if I spell right. So this is the actual Baxter website, which, shockingly, identical. One thing to note when you are looking at MSE or SSIM on websites, if there is video on the site, it will detect it as a difference because it's not looking at video, it's just taking a static image. And depending on where it's at in the video when the image is taken, it could be different. So if you know that you have video on your site such as this, you are going to want to look more carefully. You might want to expand your threshold for, oh, this has video, so I want to look at 0.7 and above instead of 0.8 and above. Just adjust on the fly because it's entropy, essentially, so you're going to have different scores. If we come back over to my shell here, so as we scroll back down, as we can see, it is taking the screenshots and it's writing them all to temp. And if it cannot get a screenshot, it'll throw an error and then keep on going. Where is it at here? So if you see there, it says, let me pause this so I can actually. So if we look at the lines here, we've caught the screenshot for the next domain that it detected. It goes through, it's comparing them, and then it's telling us here that Baxter.com is different than BaxterJ.com with a score of, I can't read that, I think it's 0.82. Yeah, it's a lot easier in a terminal when you're right in front of it. But so that's how it goes through and it gives the output. This will all also be written to a file at the end. So if you want, you can just go back and this is all done to a CSV when you run it instead of being all pretty like this. So that way you can pass it to your takedown system or anything else. If you want to do more with this than what it's doing now, you can specify the DNS recon option, and it will do a DNS recon style report for everything it discovers. And if you give it the option, if you give it the -n flag, it'll go through and it'll nmap and get you back all the banners for any open ports. So that if you decide to be like NVIDIA, you can think about backhacking but probably not the best idea. So let me close my shell here. Where's my mouse? All right, let's. So, go past. All right. So, additional features, I did kind of just touch on most of that. It will also return full whois information into a file for you. You can, and another thing that recently was added to this, you could specify a TLD dictionary to extend it. So by default, it only looks at the similar TLDs to what you're looking at. If you say you wanted it to go through and you wanted it to start looking at like co.za or any of the weird new like .club, .whatever ones that you want that have come out, you can give it a TLD dictionary and it will go through and it will test. It'll run through and generate the permutation list, and then it will enhance that by adding those TLDs to every one that it finds and replaces the TLDs with those, and it'll run through all of that. And that's a great way to go from a list of about 50 to a list of about 500 potential attacking domains. You can also specify a custom user agent with it for in case you somehow get limited for for like a WAF rule for Cloudflare. You can also just have it generate the permutations and dump it straight to standard out. And you can also give it a dictionary file for adding to the permutations for like adding words or moving words from your domain. And that's pretty much all the features that it has additionally. So I know some people asked questions earlier on. Does anybody else have any other questions?
Once you manage to kill off all these impersonators, do you expect this just to be a background task that just runs periodically and kicks off an alert of, hey, I see something close again? Mm-hmm.
Yeah, the way we've been doing it right now is it's manually run once a week, and we've actually got a platform that the guy on our incident response team just wrote called Automator, that where any tool that you want to give it, it'll run, and you can pipe the output from that into any other thing. And so right now we're manually running it, but as the landscape changes, and so the more domains that we detect, the faster we'll start to. The more eventually it'll become a background task, but for right now it's still very hands-on because every time we run it, almost we find something new. So and like I said, we've taken down about 25 so far. And if the registrars don't work with us for our takedowns with that, we just pass it off to our partners at the FBI and CISA, and they'll help us out with that.
What do you see as their intent of, why have they made a clone of your site? Or are they trying to redirect business to be through them, or what's the plan?
So we've seen two different attacks so far with what we've detected from this. One is where they'll send email that's supposed to look like it's coming from us to our suppliers to try and order. We had one that they tried to order 500 Dell laptops as us, but sent to their receiving, and that's one. And the other side of it is phishing users. So that Baxter with the umlaut, we're pretty sure is for phishing users directly, because like I said, we did discover that it has the beef JavaScript hook for the browser in it. So
wouldn't they then have had to have extracted email addresses from your system to then have someone to target?
Not necessarily. Well, yeah, you can do.
Or they would hope to.
Well, hope. Or, I mean, honestly, we've been seeing more and more people just scraping LinkedIn and getting employee names and using that to generate email lists. Or if they want to spearfish, they go through and they find specifically our C types and go like 1 or 2 levels below that. And once you figure out the naming scheme for a company's email lists, and with this, it's super easy. Or like even for us, or even your orgs, like how many of your company's websites have valid email addresses in it, right? So as soon as you know what the email address format is, you can just go through and grab LinkedIn, pull it down with an API, and just make everybody's email, and then try whoever you want. So, anything else? Okay, well, thank you.